Hello, class. I'm here to talk about chapter 11 and the last problems assigned for chapter 11. Actually, there are two problems, but they are divided in several little questions. For the first one, you really only have to answer two questions, very simple questions. I mean, you're going to be doing the p-value, but I'm going to be showing you that. And then I haven't even put here the other one that I'm going to be working on it next. And we'll be done with the videos for week 6. Chapter 11 is talking about the chi-square distribution. The chi-square distribution is just another type of hypothesis testing. Okay, that's why it goes along with the hypothesis testing subject. The chi-square allows you to compare observed values from expected values. For example, excuse me, you're gonna buy a restaurant. Let's suppose you decide to buy a restaurant, and that restaurant um, it's known to be very popular. You see lots of clients come in and out, customers, sorry, coming in and out every day. So now you decided to um, really see if what your perception, how close it is to the reality. So there's what you expect and what you actually observe. That's what the chi-square is going to help you to show you if the perception you have, does the perception you have, is it, should I say, supported by what you observe? Did I say that correctly? If the expected, what you expect is really supported by what you observe and vice versa. So there are three types of chi-square distribution. I'm only going to be going over the goodness of fit test, which I have assigned very few problems. So it shouldn't be that confusing, hopefully. And then we'll be done with chapter 11. And next week we can jump into linear regression. And linear regression is actually going to help you for the second portion of statistics. Okay, few things. Let me go back here. The chapter begins as telling you examples. Have you ever wondered if lottery numbers were evenly distributed, or if some numbers occur with a greater frequency? So you're going to be testing the observed, the expected, and right here it says in this chapter you learn the three major applications of the chi-square distribution: the goodness of fitness, the the goodness of fit, which will determines if data fit a particular distribution, such as the lottery, and then the other two would be the test of independence, which determines if events are independent, such as a movie example, and the third one, which is going to test the single variance. Again, I'm only going to go over the first one. Some facts about the chi-square distribution. Let me see, the degrees of freedom here is going to be very important, which the degrees of freedom actually is going to be k minus 1, but k is really going to be your category, and we're going to go over that. Let me see, the curve is non-symmetrical and is skewed to the right. There is a different chi-square curve for each degrees of freedom, which that means there is a table for the chi-square as well, where you are presented with the degrees of freedom and you're presented with the percentage. But in this case, I'm gonna give you the formula to use in Excel, so you don't have to go through the table. Okay, and that way you're gonna always be getting exact amounts for your p-value. The test statistic for any test is always greater than or equal to 0. And when the degrees of freedom, they're very high, they're, for example, right here, higher than 90, the the chi-square curve approximates the normal distribution. So the higher you guess, this curve is actually gonna looks more like our normal, just like this COT, this central limit theorem, that the larger the sample got, the more it got closer to our normal distribution. Okay, let me see. The mean is located just to the right of the peak of the chi-square distribution. Let's go to the goodness of fit, which we're going to be using this formula right here, which all it's showing you is that the sum of your values is equals to the sum of your observed values minus your expected values squared divided by your expected values. That's how we're going to calculate everything to get to your chi square t statistics, and then from there we can calculate the p-value, and then we're going to compare to the alpha just like your hypothesis testing and see whether we reject or we fail to reject the null hypothesis. The goodness of fit test is almost always right tail. This is very important. Okay, so when I use the formula in Excel, I'm going to use for the right tail. And then it gives you examples. Another thing that the null hypothesis and the alternative hypothesis, they are actually expressing sentence. You're going to be seeing full sentence. Okay, it says, uh, if you read the chapter, uh, it is going to tell you about that the chi-square is always shows you the null and the alternative in sentence. So let's go to the problem, which I have spent quite a few time, but I was just trying to summarize the chapter. Let's go back here, and I put problems 10 and 12. You need to answer 10 and 12, but I have put everything because I'm gonna have to go over just to give you all the basics of the chi-square. So the problem is saying use the following information to answer the next 5 exercises. A teacher predicts that the distribution of grades on the final exam will be, and they are recording the table. So her prediction, her expected values are right here on this side of the table. Okay, you're gonna know why I put this over here. And then if you continue reading the problem on your book, you're going to see, but the actual values after all were over here. Well, if you notice here, it's showing you in percentage. And here is showing you how many students, each student got this grade. So what you need to do is to either or, but what we're going to do, and another thing that it tells you on your problem, which let me see if I can find the problem. Where is it? 10 and 12, correct? Right here. Yeah, I should have put the rest of the problem. Right here, the actual distribution for a class of 20. So the actual distribution for a class of 20. So right here. So this is an actual distribution for a class of 20. Is this. Therefore, if this is the percentage, we can do that equals to 20 students times 25% is 5 students. And then we can do for the rest. We can do 20 students times 30%, the same as 6. And then 20 students, I could just drag it down, but I want to do it so you can see it, times 35%, and then 20 students times 10%. So we have, so this were the expected. She expect 5 students to get an A, 6 to get a B, 7 to get a C, and 2 to get a D. And in reality, 7 got an A, which is great. 7 got a B, 5 got a C, and 1 got a D. Okay, so he actually was better than what she expected. Um, I could go ahead and, oh, another thing very important right here. Let's answer. Uh, problem 9, which I didn't ask you, degrees of freedom. Let me go over here. The number, this is what I was looking for. The number of degrees of freedom is equals to the number of categories minus 1. The number of categories minus 1, not the number of students. Therefore, how many categories we have here? A, B, C, and D. Therefore, we have 4 minus 1. So your degrees of freedom is 3. Okay, very important. I just told you that we're gonna state the null hypothesis and the alternative hypothesis in sentence, correct? So the way you can do this is to say that your null hypothesis, it helps if I take that out, is the observed class grades fit the expected grades. Okay, we're trying to prove that. Not prove, incorrect wording, I'm sorry, hypothesis. We're trying to see if we have enough evidence to support that. Okay, so my alternative then, it's gonna be that, let me just go ahead and copy this. Well, if the no is that it fits, so then the alternative would be that the grades do not fit. Okay, there, my chi-square test statistics. That's why I have the rest of the formulas over here. Where did I get then? From the summary of your book, which I put it over here. So over here, I'm gonna have in the end, right here, I'm gonna have this formula. The sum of the observed values minus the expect values squared divided by the expect values. Okay, so I did one by one so you can see how I get to the end. You can go ahead and, I'm gonna go ahead and hide the information you don't need right now so you don't get confused. Here we go. Let me just type this. Here was the expected, correct? So let me put E. So therefore, equals to my observed value right here minus my expected. The actual value minus the expected. And then you do it again, the bottom one. So you're going to do equals to my observed minus expected, and then observed minus expected, and lastly, observed minus expected. However, right here it says that the numerator is the observed minus expected square. So what I'm going to do, I'm going to square these values that I just got over here. Okay, let me do with values so you can see. Caret 2. Okay, so you're gonna do the same thing. I'm just gonna drag it down. So 2 times 2, 4. Something is wrong. Yeah, I'm glad I did that. What happens is I put a value and I drag it down, so I just copy the values because I didn't put a cell. It only works if you refer to a cell. So I'm actually glad I saw that. Here you go. So 2 times 2, 1 times 1, minus 2 times minus 2. You know, the minus plus minus is a plus. 2 times 2 is 4. Minus plus minus, it's a plus. Then 1 times 1. Okay, so now we have this top portion right here. And now we want to do this top portion divided by the expected value. So we're going to do equals to the top portion divided by my expected value right here. Okay, then just drag it down. I drag it down because I put cells. If you put the values, you gotta be very careful. If you drag it down, it's gonna modify it. Okay, and another thing I noticed on the midterm, if you are referring to one specific value somewhere else, you need to lock the cell. Press F4 on your keyboard to lock a cell. Okay, so now we have done this, but it's telling right here the sum of all of them. So then let's go ahead and let's sum them. You can just click here, auto sum. Just be careful that it select the cells you wanted. Here you go. So you found this value. You're not done. Okay, but this is gonna help you for the next one. So I found this value right here, which I'm just going to do equals this value. Okay. And now we're going to calculate the p-value. The chi-square also has a table, but I don't want to, at this point, confuse you more. You can go and find a table and look it up. But the easiest way I'm going to show you right now. Remember what I said, the goodness of fit, right there is almost always right tail, correct? So what we can do, Excel has a formula for that. So let's start typing chi, which is start with the C. So chi, oh, here we go. See where it says chi-square distribution right tail. Chi-square distribution right tail. Right here returns the left tail right here. So if you had a left tail, and right here right tail, here returns the inverse of the left tail, right here the inverse of the right tail, and returns the test for independence, which is the same as is going to give me over here. So let's use the right tail. Chi-square distribution for the right tail. My x is actually my test statistic. They worded x, but it's my test statistic. You can refer to here, or you could just type. I'm going to type. Remember, if it's negative, you need to put it positive. Okay. So degrees of freedom, what is it? 3, correct? That's why we calculated this. And then you're going to do enter. And this is it. So your p-value is 5641.5641. Excuse me. So actually 56 percent, right? So on the problem, if you go back to your book, it's gonna ask you, which is the last one. I put in here, you don't need to answer. I'm just gonna show you, okay? Since we're not doing the other types of chi-square. So at 5%, well, we're gonna follow the same that we did before with the hypothesis testing so many times. What is your alpha value? Is 0.05, right? So your p-value is 0.56. Okay, so let's take a quick look. Is your alpha is less than, correct? So therefore, so let me put the actual symbol. Um, Less than, close, is less than, therefore, what do you do? So what do you conclude? Do not reject the null hypothesis. There is not enough evidence um, to suggest that the observed test scores are significantly, I think I misspelled something, right? Significantly, only one L, right? Different, something's not right there, is it? No, it is right. Different from the expected test scores. So do not reject the null hypothesis. The observed classes grades fit. Well, it's not that much that we can reject it. And then you would be done with problems 10 and 12. And I'm going to go over the last problems, which should be everything. Let me take a quick look here. 26. Yeah, see right here, you're going to start with this information. So I'm going to answer this, which is going to follow the same principle as what I just did. And then we're going to be done for this week. And that's all